Welcome back, everybody. Nice and chill in here today. Not much talking, just nice and it's a good mood in here. Very low key.
Very mellow.
Very mellow. It's a good mellow. All right, so let's go over the homework. Again, the goal is we're gonna go over the homework. Do the lesson for today. Not too much for the guy to do. Just some time for imitation stuff. And then I'll let you work on your homework in class. Sound good? Okay, let's get to it. Let me ask you guys for some answers. Don't forget, if you haven't submitted already, please do so. Second period. All right. Hannah, what did you get for number 1? 1/16. Good. Oh, that's not a pencil. 1/16. Good. Carson's not here today. Mr. Haas, what did you get for number 2?
-1.
Just 1, yeah. Number 3, Ben, what'd you get?
1/-36.
Good. 1/-36. Number 4. Berkeley, what'd you get there?
1/-1.
Good. Yeah, I would say 1/-1 would be fine. You could reduce that down to just -1 if you wanted to. Alexis, what'd you get for number 5?
1/-9.
It should be 1/+9 because you do the -3 still in parentheses, and that'll turn it to positive. Mackenzie, what'd you get for number 6?
1/125.
Good. 1/125. Liam, what'd you get for 7?
1/-343.
1/-343. Good. And number 8, Hayden. Sure, Hayden. Mothman. What'd you get for that one?
I don't know.
Oh, come on now. What would you do then?
Do the fraction thing.
The fraction thing, yeah.
Yeah.
1/-4 to the positive 5th power. You got your calculator?
Yeah.
Do -4 in parentheses to the positive 5th power. I don't know that one. I'm pretty good at math. Should be a pretty big number.
-1,024.
Oh, you didn't use parentheses.
Yeah, I did.
You didn't put the 5 on the outside of the parentheses then.
Yeah, I did.
And then you did something, and then your calculator's junk. Does it look exactly like this? Oh, -4 to the 5th.
Yeah.
Oh, I'm sorry. Oh, the math teacher's junk. That's who's junk. It should be negative. It should be negative. He's like, yeah, I did. Yeah, thank you, Will. We're gonna be on that. So thank you, Will. Thank you, Will. If it's an odd power, the negative will stay. If it's an even power, it'll go. Okay. I was thinking about the 4 being even. Whoops. Okay, there we go. Back on track. It's before 9 o'clock. I can make mistakes. Serenity, what did you get for number 9? 1. Good. Good. All right, let's take a look at these middle ones. Now, I got to tell you guys, the ones on the quiz that we'll take next week, the ones on the quiz, I'm not going to put a lot of these on the quiz, okay? It's going to look more like 16 and below, okay? But anyway, we can still do it though. Again, some of them I like to reduce and then plug in. Some of them I like to plug in, then reduce. So in this case, I have the y to the 3rd on the top over the x to the 4th, which means I've got 3 to the 3rd over 2 to the 4th. 3 to the 3rd is 27. And then 2 to the 4th is 16. There's my answer there. Number 11, the R and the S both move downward, but the 5 stays in the numerator. So that gets me a 5/3 to the 3rd times 1 to the 6th, which is 5/27. Number 12 is one of the ones where I like to plug in first. 3 minus 6, and then raise that to the -4. because that would be negative 3 to the negative fourth, or 1 over negative 3 to the positive fourth, which is 1 over 81. Number 13, the 2 stays on top, the negative 2 stays on top. The a to the first goes to the bottom, the b to the third goes to the bottom. So that gives me a negative 2 over 2 times 3 to the third, so it would be, those 2's will cancel, negative 1 over 27. If you've got 2 over 54, negative 2 over 54, you were really close, you just got to reduce that fraction. Number 14, another one where I'd like to plug in first and then go and then simplify. Negative 2 times x is negative 2 times y is 1/2, and then I'm going to raise that to the negative 3. The thing I like about this is that when I multiply that out, negative 2 times negative 2, those will cancel, times 1/2, that's going to get me a positive 2. Just a 2 to the negative third. So 1 over 2 to the positive third, or 1/8. Same thing for 15. I'm going to plug in and then simplify. So 4/5 times m is 10, all raised to the negative third. So that's going to get me, well, 4/5 of 10, that's 40 over 5. 4/5 times 10 is 8. 8 to the negative third, or 1 over 8 to the positive third. I don't know that one off the top of my head. 8 to the third is 5/12. 1 over 5/12. Any questions through 15? I know those were weird ones.
Wait, did you say? Oh, 5/12.
Yeah. Okay. I'd like us to go through these. Let's do number 16. Mason, what'd you get for 16?
1 over x to the third power.
Good. Number 17. Mr. Schembeck. 1. Good. Number 18, Mr. Baker.
1 over 9.
1 over t.
1 over t to the 9.
Good. Rosalie, what'd you get for 19? Good. Number 20. Oh, number 20 is kind of weird. Joey had number 20. Number 20 is kind of weird because the 3 and the 2 stays in the top, the 3 stays in the bottom, and then the x to the negative fourth, that turns into x to the positive fourth in the bottom. That's the way that I would write number 20. Number 21. Tyler, what'd you get for that one? Leave the negative on the bottom there. Do you see how there's a negative in front of the a? That gets carried along for the right as well. Okay, let's keep it going a little bit. Finish these last 6 off. What did we get for 22, Elena? Good. Yep. 10s to the fourth over r to the third. Will, what'd you get for the next one?
E to the third on top, c to the second also on top, and on the bottom d to the third.
Good. Number 24, Travis?
5 over x to the second, y to the third.
Good. Yeah, the x and the y both move downward. The z goes away. 5 stays on top. Let's take a look here. 25. Nevaeh, what'd you get for 25?
X to the third over r to the second, p to the ninth, and then q to the fourth.
Very good. Yeah. I'll do the last couple. Final answer for 26. A gets canceled out. C to the third goes to the top. B squared D in the denominator. And our last one, number 27. G to the third is happy on top. K is coming up with it. J is coming up with it. H is the only thing that gets moved down to the denominator. That's a K to the first power. Sorry, my handwriting before. All right. Any questions through 27? I'll tell you what, guys, that last little bit in there, those numbers, the middle one through 27, that's like a bulk of the stuff that's going to be on the quiz. All right, number 28, some word problems. 28, 29. A micrometer is an instrument that can measure the thickness of an object very accurately. It's actually this really cool thing. It looks like little like claws almost, and it'll like clamp down on it, and then has a little reading of like how thick that thing is. It tells you like how thick gauge wires are and stuff like that, like for electronics. But 1 micrometer is accurate because it can measure really small things. You've got to use negative exponents. So 1 micrometer is accurate to within 10 to the negative 4th inches. So a really, really, really small amount of an inch. Evaluate that expression. 1 over 10 to the positive 4th. Now we'll talk a little bit about powers of 10 today, but basically what we do there is we take that power and that's how many zeros we have. 10 to the 4th.
That's only with 10.
That's only with 10, yep, powers of 10. So it's a 1 with 4 zeros after it. So 1/10,000th of an inch. That's pretty accurate, right? That's extremely accurate. It's accurate to 1/10,000th of an inch. Number 29. That same problem. An object is being measured by a micrometer. It has a thickness of 6 to the negative 3rd inches. Okay, maybe it's a wire or something. 6 to the negative 3rd. Evaluate that expression. That's 1 over 6 to the positive 3rd. So a really small amount, 1 over 6 to the, actually, let me just do 6 to the positive 3rd, which is 2/16. So it's 1/216th of an inch. Question? All right, let's get to our guided notes then for today. How many of you guys have talked about scientific notation before? I mean, like, everybody should raise their hand, right? You guys know what scientific notation is? Can someone explain to me what is scientific notation?
You get into the science class, right?
It's the notation that you use in science.
Mm-hmm.
It's scientific.
Well, this is where we put the 6 zeros, right? Mm-hmm. So you gotta carefully put it on the right, you put it on the left, the negative goes to the left. Yeah, this is the first thing you learn in science.
Really?
I think so.
Cool.
One of the first things.
So what is scientific notation? Somebody explain to me what scientific notation is. Somebody explain to me. And
The amount of zeros you put after or before the number that you do.
okay, good. Scientific notation is basically a way to write, it's a different way to write a number using a bunch of zeros, right? If there's a bunch of zeros within a number, you can write that number in a really short way. Now, to do that, we need to discuss powers of 10 because scientific notation relies on powers of 10. If you don't know powers of 10, then you don't know scientific notation. So let's talk about powers of 10. We just talked about this one, right? We just talked about this, so 10 to the 4th power. And I said, basically what you do is you take a 1 and then you write, if it's a positive 4, you write a 1 and then that many zeros after it. How many zeros? The power many zeros. So in this case, 4. 1, 2, 3, 4 zeros. And so 10 to the 4th power is 10,000. 10,000. Okay. Another way to think about it is we had a 1 and then we had a decimal place directly to the right of the 1. We want to move the decimal place 4 times. That's the amount of power. So I go move it once, move it twice, move it 3 times, 1 more time, and then fill in the number of zeros. That's another way to think about it, and you get the exact same number. That's the way that we think about it with negative exponents, like 10 to the negative 6. Remember how I stressed to you no decimals, no decimals, no decimals? Yeah, we're going to break our rule here because scientific notation relies on decimals. All right, 10 to the negative 6th power. You know, we might have said before today 1 over 10 to the positive 6th power. So that'd be like 1 over 1, 2, 3, 4, 5, 6. right? 1 over 1 with 6 zeros. But here's what I can do to write it as a decimal, because this is really 1/1,000,000th, right? 1/1,000,000th. Well, to do that, I take my decimal place. Instead of moving it to the right, I start adding on zeros to the left of that 1. So what I do here is I start moving the decimal place, and I move it 6 times. 1, 2, 3, 4, 5, 6. So it is 0.00001. Right? That's the decimal. Point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1. I like people say this. You write 6 zeros, and then the decimal point just goes right after the first one. 0.00001. 6 zeros all in total, including the one to the left of the decimal place. Take a look here. 10 to the 9th. When it's a positive power, you just write 9 zeros on the end of it. 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. What number is that? 1 billion. That's my bank account. Yeah, right. Take a look at this one. This is more like my bank account. 10 to the negative second power. 1 over, we could write it two ways. 1 over 10 squared, which would be 1 over 100. But with scientific notation, we're going to need it as a decimal. 0.01. Which those two things are equivalent, right? Look at the fraction. Read the fraction. 100. Is it 100.01? Yeah.
You're right.
1 centimeter. All right. Now we're going to do it the opposite way now. Now, is this going to be a 10 to the positive power or negative power? Positive. It's writing a big number as a power of 10. What's my exponent? 6. I see 6 zeros there, so it's 10 to the 6th power. All right. Is part B going to be a positive or negative exponent? Negative. What's my power? -4. I see 1, 2, 3, 4 zeros, including the one to the left of the decimal place. If I want to think about it this way, to get it back to 1, I move the decimal place 1, 2, 3, 4 times to get it back just to 1. What's 1,000? 10 to the what? Third power. And then what is 0.1? 10 to the -1. Good. 10 to the negative first power. That's kind of a tricky one because it almost looks, how many zeros do I actually have in just one? Questions about that? So hopefully we find powers of 10 pretty easy. Now let's take a look here. I know this isn't scientific notation, not yet. But I want to find the value. When it says find the value of the expression, I'm saying write it out. Write it out. Expand it. Here's what I mean. If I have 23.89 and I multiply it times 10 to the 8th power, basically what I'm going to do is move that decimal place 8 times. And since it's a positive power, I move that decimal place 8 times to the right. So this becomes 1, 2, 3, 4, 5, 6, 7, 8. There's my new decimal place. And then I fill in with zeros. Okay, so this is 2, 3, 8, 9 with 1, 2, 3, 4, 5, 6 zeros on the end. 2,389,000,000. Questions about that? All right. If I have 467 times 10 to the -3rd, All right, well, 467, the decimal place is right to the right of the 7. So what I'm going to do is move that decimal place to the left now. To the left because it's a negative exponent, and I move it 3 times. 1, 2, 3. So here's my new decimal place, 0.467. Questions about that? Let's do the same thing here. You know, why don't you try the next two? Write out C and D real quick. All right, part C here, 853. Oh, 853.4, and then I'm going to take that decimal place and move it to the right 5 times. 1, 2, 3, 4, 5. There's my new decimal place. So that gets me 8534 and then 4 zeros. So 85,340,000. And then we've got 0.163. And then I'll move that decimal place to the left 2 units. 1, 2. Why to the left? Well, because again, it was a negative exponent. So 0.00163. Questions about that? Now, that is not technically scientific notation. None of these problems that I had on this slide were technically scientific notation because scientific notation is basically a method of writing numbers that are very large and very small. And it's got 2 parts. These look like scientific notation, but it's not exactly scientific notation. Oops, it got kind of messed up a little bit. Hold on, that's kind of pause. There we go. Because the first part has to be a number between 0 or between 1 and 10. Okay? Basically this, you can only have 1 digit in front of the decimal place. If you've got more than 1 digit, or less than 1 digit, I mean, if you've got a 0 in front of the decimal place, that's no good either. Okay, you need to have 1 digit in front of the decimal place. And then on the right side, you'll have a times 10 to the, and then a positive power or a negative power. So in essence, what is scientific notation? I like to think of it this way. You know, way back before the time of computers, when everything had to be handwritten out or typed out, I mean, there's a lot of error that can occur if you try to add really big numbers together, or multiply really big numbers together, or do any sort of operations with really big numbers. You could make a lot of mistakes. Oh, I forgot to write a 0 there. Like if I'm talking about millions and millions, well, I dropped the decimal place here or there, that's a big bummer, right? So what scientists decide to do is create this thing called scientific notation, where it's a shorthand way of writing those numbers so that you don't lose track of all the places. You don't lose track of all the numbers. And the numbers are so big and they're so small they're kind of negligible on either side, so it doesn't really matter the rest of those numbers on the right side. You kind of bring it out to just a 1 or a couple numbers right in front and behind the decimal place, and that's all that really matters anyway. So let's talk about this. When the book asks for things that are called standard form, that just means like write it out, okay? Write it out, not written in scientific notation. So it says Saturn has a diameter of about, I don't know where that got a little small. Here we go. Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Its distance from the sun is about 1,427,000,000 kilometers. Write Saturn's diameter in standard form. Okay, the diameter needs to be in standard form. The diameter is already in scientific notation. This is scientific notation because I see one digit in front of the decimal place times 10 to the, and then I have a positive power. Remember, scientific notation is a way to write really big numbers in a shorthand way. Right? This is a really big number. Take that decimal place, move it to the right 1, 2, 3, 4, 5 times. So Saturn's diameter is 120,000 kilometers. 120,000 kilometers. 1.2 times 10 to the 5th power. 120,000 kilometers. So when it says to write it in standard form, just expand it out, non-scientific notation. All right, so what about if I wanted to write Saturn's distance from the sun in scientific notation? Well, the distance to the sun, let me bring it down here, is this big number here, 1,427,000,000. 1,427,000,000. Okay, that's Saturn's distance to the sun, but I want to put it into scientific notation. So I've got to go all the way up to here. I want my decimal point to be 1.427. You need one digit in front of the decimal place. So it's going to be 1.427 times 10 to the something. And now I've got to figure out how many decimal places I move it to get it to be 1.427. So it was here, right? I want to do 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th power. And that is the distance from the sun in kilometers in scientific notation. Okay. Questions about that?
Why would you try to behind the 7?
Because that's not technically scientific notation. You've got to go one digit, then the decimal place. All right, let's do another example. The Pacific Ocean has an area of about 6.4 times 10 to the 7th square miles. Its volume is about 170 million cubic miles. Write the area of the Pacific Ocean in standard form. Okay, I want to look at this in, again, standard form. The area in standard form. This 6.4 times 10 to the 7th, writing that out. Since it's a positive exponent, remember this is a really big number, just written in a shorthand way. So I move that decimal place to the right 7 times. 1, 2, 3, 4, 5, 6, 7. Fill in my zeros. So it's 64 million. 64 million miles. What does that sound? 64 million miles. And then I want to write the volume. Looks like I want to write the volume in scientific notation. Well, the volume is that 170 million. 170 million. Okay, well, if I want 170 million, that's 3, 6, 8. 1.7 times 10 to the 8th power. Miles squared. Miles cubed, sorry, it's volume. That should have been miles squared. Questions about that? Last thing we'll do here is write out things in order from least to greatest or greatest to least. Okay? So take a look here. I've got these commas here separating the things. I'm going to make it a little bit more evident. To compare these two values, I need to put them in the same place, like same, notation. Look, they're all scientific notation, right? What's the very smallest number that I have on this list? Well, 1 times 10 to the negative fifth. That's my very smallest number. Okay, so that one's gone. What's the next smallest number? Well, I see 2 negative 3s, don't I? Okay, so which one's smaller? 3.6 times 10 to the negative third or 4.1 times 10 to the negative third? You sure about that?
3.6.
3.6.
Why?
Because I'm not talking about a negative number, I'm talking about a small number, right? You would be correct if this was like negative 4.1. You're right, negative 4.1 is smaller than negative 3.6, but I'm talking about a decimal value, right? If you were to truly write this out, this would be 0.0036. This would be 0.0041. Which one's smaller?
Great point.
That make sense?
Yeah.
So I would do 3.6 times 10 to the negative third, and then 4.1 times 10 to the negative third. Those go away. And then obviously my next one up would be the 2.7 times 10 to the second. And now I've got 2 to the fourth powers. So I go with the smaller value, 1.3 times 10 to the fourth, and then 3.1 times 10 to the fourth. Questions about that one? Last thing here. I'm just going to change from set. We're just going to practice a little bit more into signs of notation. So I want you guys to do these last 4 real quick and try to see if you can put those into signs of notation. Go ahead and do that. I'll give you a minute or two. Just put those last 4 into signs of notation. All right, let's take a look. 34,145 should be 3.4145 times 10 to the what power?
4.
Fourth. Decimal place was here. It goes 1, 2, 3, fourth power to get right there. Taking a look at part B there. Bring that up. Oh, that's all one image. Okay. Part B. What should be my number in front of the times 10 to the? Should it be 0.678? What should it be, David? 6.78. Oops, sorry. 6.78 times 10 to the what? Negative 1, 2, 3. Remember, it's a small number, right? I've got to use a negative exponent to represent the small number. Negative exponents are small numbers. I get 2 different answers for this one a lot. I get 1.25 times 10 to the 8th. Oh no, sorry, to the 7th. And then I get a lot of people try to tell me 12.5 times 10 to the 6th. Which one's right? Or are they both right? Hayden?
The first one's right because it's not in, like the second one, it has to be between 1 and 10, and this has 10.
Yeah, look, 12.5. I can't have 2 digits in front of the decimal place. It's got to be 1.25 times 10 to the 7th. It is a correct representation of that number, but it's not technically in scientific notation. Then the last one here, looking at the number, the decimal place needs to go right here. So it needs to go 1, 2, 3, 4, 5, 6, 7 units. 7.5936 times 10 to the positive or negative? Negative. What'd I say?
7.
7. There we have it. Questions on that? All right, we did a lot today. So long, everybody playing along at home.